Welcome guys to our video for our demo project for Dynamics. So we have built a catapult for this project. I'm sure everyone knows how it works, but basically there's this wooden dowel in the middle. It runs through these two pre-drilled holes. We have our arm and then the box for the weight on one side. On the other side, we have a cutout piece of PVC for the projectile, and our projectile is just a regular golf ball. So how it works is we have our 1.5 pound counterweight in the box, pull it back, load the golf ball up, set it loose, and it falls into the predetermined distance, which is 81 inches. And now that I have talked to you about the catapult and shot it for you, Eric's gonna hop in and talk about some of the boring math behind it.
All right, so just to talk in simple terms about the dynamic properties of our design, if you consider the counterweight at the initial position before we release it, the counterweight is holding all of the kinetic energy that we can find from conservation of energy. Our second position would be down here at the resting point, right before the ball is launched, and then it transfers this the potential energy into kinetic energy, and we can use conservation of energy to find the final velocity. So we know the resting velocity is 0, and we have the mass, and when we get down here, we can find our final velocity based on the difference in height. Once we have that final velocity, we can translate it into angular velocity based on the radius from our axle, and the angular velocity will be the same between the two sides, between the counterweight side and the projectile side. The difference is that the radius here is much larger, so we're now transferring a lot more velocity from the shorter side to this side. And so then after we find the velocity of the ball here, we know that when the ball is launched, it's then launched into projectile motion. And so it's no longer accelerating through the swing arm in the X direction, it's only accelerating downward because of gravity. And using that, we can find the exact distance that it'll travel and make it in the bucket every time.
So using the same weight every single time, which is 1.5 pounds, when we launch it from the same point, it will go to the same spot every time. We're going to do it 3 times to demonstrate.
All right, so by launching out of our catapult without any weight, just with the weight of the box, the projectile lands at about 32 inches. Then adding the 1.5 pounds, it lands at 81 inches. And then, so if we take the difference between 32 and 81 to 123 inches, 3 pounds of weight in our counterweight should get us to 123 inches. So let's see if we can make that happen. All right.
Perfect.